Now we start a new lecture which is on connected vehicles. So, connected vehicles has become very popular in the recent years. There is a lot of research that is going on building connected vehicles for good reasons. What are these different reasons? So, standalone vehicles embedded with different sensors has been there since several years now, if not decades. So, these standalone different vehicles, we all are using different vehicles and these have different embedded sensors, embedded systems and so on. But in connected vehicles, actually we are talking about how we can make communication between different vehicles possible. So, what kind of communications? Communication between a vehicle, one vehicle with another vehicle, communication between a vehicle and a pedestrian user or another user who is not there in the vehicle, vehicle and the roadside infrastructure or the existing infrastructure in a city. So, all of these different possibilities are there in a connected vehicle. So, let us look at this particular example. So, let us say that we have, so we are talking about a scenario to motivate why connected vehicles are required. So, let us say that we have these different vehicles on the road. So, every vehicle has its own different sensors and it can even be fitted with more sensors, more communication equipment and so on, even further it can be done. So, if we talk about a single vehicle in a connected vehicle scenario, this vehicle could be talking to the immediate next vehicle, the neighbor vehicle. This vehicle could be talking to this one, maybe with the either directly or with the help of some intermediate vehicle which is there in its neighborhood. This vehicle could be talking to a roadside person, so this connection flow, this communication flow might be possible, or there could be these different existing communication infrastructure with which this information exchange may also happen. So, you can have V2I, V2V, vehicle to infrastructure, vehicle to vehicle communication, vehicle to human or even human to vehicle. And when we are talking about human, we are talking about the humans who are not in the vehicle, who are on the roadside. So, all these things are made possible in the connected vehicles, and there is lot of, if we look at the history, there has been lot of, at least a decade or decade and a half, there has been lot of research on vehicular communication and intelligent transportation systems, vehicular ad hoc networks, VANETs, vehicular sensor networks. Then came these connected vehicles, then came the intelligent connected vehicles. All of these, in different forms have been around, but the different services, the different service improvements that can be made possible, people are talking about in the context of connected vehicles and these intelligent connected vehicles. So, let us look at some of these basics which will help in building these connected vehicles. So, in connected vehicles, we have the vehicles that are equipped with different sensors, networking and communication infrastructure, different devices powered by intra vehicle communication. So, remember one thing, couple of things, so what is going to happen is in a connected vehicles scenario, number one, it would be possible to communicate with the different devices inside a single vehicle, number one. Number two is between different vehicles, from a vehicle to the roadside infrastructure or a fixed infrastructure, that means a non-mobile infrastructure. So, all these different types of communication are going to happen in a connected vehicle scenario. So, issues such as security, privacy, scalability, reliability, quality of service, and on top the lack of any singular global standard for connectivity are some of the challenges that are facing the building of connected vehicles. So, if you are interested, so this particular paper that is referenced over here, proof of concept of home IoT connected vehicles, this paper you can go through. This basically gives a good account of the different issues surrounding the building of connected vehicles at present. So, this is a recent paper that was published in 2017 in the Sensors journal. So, the different challenges, for example, security. Security is very important because so you are opening up with the help of wireless and with the help of these different vehicles flying all around in the city. So you are opening up to lot of vulnerabilities are there, you are opening up, you are adding to the vulnerabilities, and additionally privacy is also very important because the vehicular data flying all across, different people can get access to that data. So, privacy of the data from different vehicles is very important. You know why privacy is important? Let us say that if the data is leaked for one reason or another, let us say that there is someone. So, I am driving and I am in a connected vehicle kind of environment, and from my vehicle the data is sent to another vehicle which is a trusted one by me, but in between the data is leaked and that data is made accessible to somebody else. So, in that case what is going to happen is the intruder or the malicious person or the entity which gets access to this data which was not intended for it. So, if that entity gets access to that data, they will know that where I am going to, for example, where this vehicle is going to, and that could be risky, that could be even a security threat, a safety threat, because not only safety threat or security threat to the vehicle itself, but also to the people who are inside. Like for example, if I am the user of the car, if I am the driver of the car, and if somebody gets access to this kind of information, even my safety, my security is also at risk. Scalability is a huge challenge. You are talking about an environment where there is lot of mobility, large number of devices coming in, going out of the cities, and you have to have some kind of a registry about who are the home users, home vehicles, which vehicles are the foreign vehicles, and some kind of pricing, some kind of keeping track of all this mobility, etc., etc. So these are going to be there, and at any time anybody from outside can be coming into the cities, people can be the vehicles can be going out of the city, and it's a highly challenging scenario. So, lot of issues of scalability, more vehicles being added, large number of vehicles being added at in peak hours, even large number of vehicles could be added. So, scalability issues are there, upscale, even downscaling also. If you think little bit deep, you will be able to understand that downscaling issues are also there. Then you have the reliability issues with respect to the reliable communication being possible in this kind of environment, quality of service, lack of global standards. So, in a connected vehicle, connected vehicles are very good, as we have seen. There are a lot of different interesting use cases, usefulness of connected vehicles. Then we have the vehicular cloud. In a vehicular cloud, what is going to happen is these connected vehicles are going to send all these data are going to go to the cloud. From the cloud, lot of analytics are going to be performed, that data, the analytics data are going to made available to the respective stakeholders and so on. So, all these connected vehicles is part, you can conceptualize connected vehicles in a as part of the vehicular cloud and connected vehicles as part of the IoT. So, these are like enablers of Internet of Things. So, the different users and the stakeholders of connected vehicles include academia, law enforcement bodies like police, judiciary, etc., law enforcement bodies, automobile companies, government agencies, standardization groups, cloud service providers. So, these are the different stakeholders, different actors of connected vehicles. So, typically in a connected vehicle, the most popular concept is the concept of vehicle to everything paradigm. So, V2X, vehicle to everything, V2X. So, V2X is basically part of the future ITS, intelligent transportation system, which enables vehicles to wirelessly share a diverse range of information, and the information sharing may be with other vehicles, pedestrians or fixed infrastructure such as mobile towers, parking meters and so on. So, this is what at the very outset of this particular lecture I was also telling you, that this vehicle can communicate with the pedestrians on the way, with the other vehicles on the road, or with fixed infrastructure such as mobile towers or parking meters and so on. So, this basically allows for traffic management, ensuring on road and off road safety, mobility for traveling and so on. So, I do not need to elaborate on this, but this is quite evident and understandable how this V2X is going to be useful. V2X basically follows a distributed architecture where the contents are widely distributed over the network. So, content based communication. So, I will talk about that. It is a content centric. V2X basically uses content centric and not really the TCP/IP kind of information dissemination approach. It is not restricted to single source information provider. It is designed mainly for highly mobile environments, and vehicular environments are highly mobile environments. It is designed mainly for such kind of environments. The vehicles can share information to nodes in the vicinity as well as to remotely located nodes. So, here V2X has greatly enhanced the travel efficiency, the safety, security and so on. The network in V2X is mainly used as a tool for sharing and dissemination of information, and that is not something very new, because ultimately what is going to happen is, after this information is collected from these different sensors, the dissemination has to happen with some communication medium, and typically it is a wireless communication medium where there is a network, and the network basically helps in the dissemination of information. Now, what do we already have in terms of implementation of V2X? We already have our internet. Internet runs on TCP/IP. So, if we try to implement V2X on top of TCP/IP, this is what is going to happen. So, it is going to fail. Why? So, TCP/IP is designed mainly for handling information between single pair of entities. There is a source, there is a destination, and between these source and destination, whether they are in direct range of each other or they are far apart, TCP/IP will have different solutions by which to send the data from one point to another. So, the location, the information exchange in TCP/IP is dependent on the location of data. So, there is a specific database located at some place. So, from that point the data has to be fetched. So, from this particular database in a particular server, the data has to be fetched. So, this is like dependent on the location of the data, can only identify, TCP/IP can only identify the address of the endpoints, which alone is not useful for content distribution, and that content distribution is what is required in the case of connected vehicles in V2X. And there is increase in the number of wireless devices, which basically restricts the mobility of the different nodes. In content centric networking, it is basically conceptually has similarities to the popular information centric networking, which focuses on the data than the actual location of the data. So, I need some data, I do not have to say that I have to get it from this particular database or this particular source. In content centric networking, what is going to happen is, if I need access to a particular data, I will be doing some kind of a broadcasting, of that particular requirement, that query, and whoever has that data is going to send me that data. So, this is how the content centric networking in contrast to TCP/IP functions. So, we have hierarchically named data in content centric networking. Hierarchically named data is something like x dot, y dot, z, this kind of hierarchy is followed. Okay. Something like my data would be something like Mishra dot, Sudeep dot, age dot something. So, it is hierarchically named, very similar. I am giving you just an analogous example, not the exact one. So, hierarchical data is transmitted directly instead of being part of the conversation. So, the conversation would be like the entire thing, this dot this dot this dot this, that becomes the entire conversation. So, this is how the hierarchical data is organized. So, I do not need to really, if I need to get access to a particular part of that hierarchical data, I do not need to access the entire conversation, I can simply pick up from that particular part. So, it enables scalable and efficient data dissemination. In network caching allows for low data traffic. It works well in highly mobile environments. So, in highly mobile environments, you do not really need to keep track of the source, the destination and the intermediate hops in between, and how the data is going to float all around. So, you have a highly ad hoc kind of scenario, and content centric networking, basically following this kind of philosophy that I just explained, is very much useful. So, we are talking about vehicular ad hoc networks, which is based on dedicated short range communication DSRC, and the wave protocol, which is wireless access in vehicular environments, the wave protocol. So, these are the two very well known protocols that are used in vehicular ad hoc networks, the DSRC protocol and the wave protocol. So, routing protocols are derived from the manets, and but here actually you have different types of characteristics than manets. It is a derivation, all these routing protocols for manets are basically derivations over from manets, but again they are different by taking the typical features of vehicular networks, how the vehicles ply on the road, on highways and so on are taken into account, and how they communicate with the roadside infrastructure, these are actually taken into account. So, high throughput is achievable in mobile environments using VANETs, and also low latency can be guaranteed in mobile environments in VANETs. VANET basically has different features. It has a highly dynamic topology, where the vehicles are highly mobile, and they are constantly changing their position, and the network topologies continuously, they break and they make continuously. So, you have a highly dynamic breaking making kind of topology which is done continuously. So, high transmission and computation capability, the vehicles store energy sources, the vehicles stored energy sources and the computational sources are used to draw power, and that basically is much higher compared to the standalone IoT devices, and that is why there is not much restriction, there is not much of restriction on the energy source, energy use and computational power and so on, because the vehicular energy sources and the computational energy sources in the vehicles, these are quite high. Unstable connectivity in VANETs, link durations are short due to high dynamic feature of these networks. These networks can be scaled up very easily to include different other vehicles on the road. They can join this particular network without affecting the throughput in a very significant manner. The predictable mobility patterns can be achieved in these kind of networks, because the vehicles are restricted within the roads, how the road structure is, and that basically restricts the mobility pattern also, and these mobility patterns are predictable in these kind of networks. In contrary, in manets, basically in mobile ad hoc networks, the mobility is a big issue. You do not know how the vehicles are going to move. It is hard to predict the mobility of these different vehicles. Safety issues are there, emergency braking, lane change warning, collision avoidance, hazard notification. These are the different safety applications of VANETs. Efficiency with respect to congestion management, electronic toll collection, parking availability, these are again different attractive applications of VANETs. Third type of applications are commercial applications, for example, having internet access, multimedia streaming, all these possible on the road, when you are on the road, in the car, in the vehicle. So, these are possible in VANETs. Then different other comforts with respect to getting weather information, autonomous driving, journey time estimation, these are all made possible with the help of implementation of VANETs. Then CCN, the content centric networking that I was telling you before, how it is implemented in VANETs. So, some sort of routing is done, but this kind of routing is a bit different. So, forwarding and routing is based here on name of the content, not the location of the content. The name of the content is used for routing. The individual content's name prefixes are advertised by the routers across the network. This helps to build a forwarding information base for each router. The name of the content remains the same and unique globally, and there is no issue of IP address management or address exhaustion. The communication does not depend on the speed or direction of the different nodes. So, these are the different issues. So, the main thing that you have to has to be remembered is there is indeed, in the same way as we have routing tables in the case of TCP IP based routing, here we also have a very similar kind of thing. We have the forwarding information base at each of these different routers, but here the routing is done not on the basis of the location of the content, but on the basis of the name of the content. So, where this and that name has to be unique. So, this is very important. If the name is not unique, then this kind of routing cannot be done. So, in content centric routing, the name also has to be unique in the network. Scalability, an in networking caching mechanism at each router is implemented, which uniquely identifies the named data chunks, and these data chunks are stored in something known as the content store, which acts as a cache. Subsequent requests for a stored data chunk can be made to a content store. The naming system in the content store enables the data to be used multiple times, unlike in the case of normal IP based routers, as we discussed before, and there is reduced network load during the increased network size as a result of the caching mechanism. Now, we will talk about a very interesting architecture, which is called the body and brain architecture, that has been proposed for the connected vehicles. So, it is an in vehicle networking architecture, which has very similar kind of architecture as the human body. As in the human body, we have the body, the core body having the skeleton, the muscles, the tissues, the organs, and this so that kind of structure. But on top we also have the nervous system, the brain, etc., and similar kind of thing is done in this case as well. So, here we have a 3-layered architecture. There is that sense and execution layer, then we have the network and transmission layer, and then we have the decision layer. So, the sense and execution layer is very similar to the body of a human body. The network and transmission layer is very similar to the nervous system of the human body, and the decision layer is very similar to the brain of the human body. So, there are 3 layers. The body consists of intelligent networking nodes, which constantly collect information from the vehicle, and then the brain basically manages the central coordination. So, let us first look at the sense and execution layer. In the sense and execution layer, we have these intelligent nodes. With the help of sensors, actuators, different radios, the information is acquired with the help of different other devices like lidar, radar, proximity sensors, and different other sensors, plus actuators such as steering, brakes, lights, etc. The information is acquired, and the commands are executed through the actuators or through the different radio mechanisms. These are made available, and this is how the sense and execution layer looks like in a connected vehicle scenario. The intelligent networking nodes, which has intelligence implemented with the help of software, different software. There are different types of nodes. One is the register type nodes, which can be open or closed. There is a motor type nodes, which basically are the motors can be moving clockwise, counterclockwise, or the motor can be stopped. Switch type nodes, switches can be of different types in a intelligent node in an intelligent vehicle. It could be, the switches could be a knob, a pneumatic switch, or an electromagnetic switch. The sensors could be rheostatic switch, rheostatic sensors. Rheostats, we already know what a rheostat is. So, the rheostatic sensors or transformers or transducers, or they could be assembled nodes comprising of different separate electronic controls. The network and transmission layer looks like this. So, this is basically this network and transmission layer, and as this name suggests, we have for communication, this is used primarily for communication. The sense and execution layer on the very bottom, and on the top we have the decision layer, and in between we have this communication layer, where there is a in vehicle bus system. Bus means that it is a collection of wire. So, we have the in vehicle bus system, and and there are different proprietary and open source components for communication. So all these put together will comprise the network and transmission layer, which is used for communication, and that basically sits in between the sensing and execution layer and the decision layer that we talk about now. In the decision layer, which sits on top of the network and transmission layer, the information is transmitted for monitoring to the administrative node, and for control of the sensor nodes, the supervisory node basically sends the command to the network and the transmission layer for further sending to the actuators underneath. So, with this we come to an end of this particular lecture of connected vehicles. We have talked about the first part of the connected vehicles, the different issues with connected vehicles, why connected vehicles are very important, and the different associated terminologies. For example, vehicular communication. We also spoke about different other allied terms such as vehicular ad hoc networks, vehicular sensor networks, then intelligent vehicular systems, then connected vehicles and intelligent connected vehicles, ICVs. So, these are the different things that we spoke about. In the next lecture, we will talk about few other different issues with connected vehicles and how those issues can be resolved. Thank you.